Hello, this is Ken McCrate, and I'm going to go over this problem in our math book that's on page 136. Now, this problem shouldn't probably be there in this book because it's a little bit more complex than uh, the other problems that are there. But that's beside the point. It's there. It's what we got to work with. So here we go. One of the things that you might notice is right at the very, very top here, and I don't know if you can see that or not, but I think you can. It says using colored markers, trace the isosceles triangles in the drawing below. Well, and then you've got to solve for this E, you got to solve for F, and you have to solve for D, which is the big angle. So I'm going to go through this step by step for you, and I'm going to show you how these angles come about, how you develop them, and what you're going to do from there. Now, one of the things that I'd highly recommend that you do is always, 100% of the time, start wherever you know that you've got a 90 degrees. So we know that we've got a 90 degrees from here down to this point right here. Why? Because it's where a radius and a straight line connect. So you know you're going to have a 90 degrees here, like that. Okay, I'm going to try to get that kind of straight so you get the idea. All right, so let's connect that angle now. We know that we've got to project this up here. And then we've got to project this over here like this. All right? Now, why didn't I project it here and then come back down? Well, this doesn't connect, does it? It doesn't really have a connecting point. If I put this here and I drew the line over, it doesn't connect. It's not at the 90 degrees. It would be if I made it that way. This is an imaginary line, but I don't need to do that. And yes, of course, you could connect this, bring it way up to here and bring it across like this, and also have in this piece right here, but we're not going to worry about that for right now. But what we do know is that we have 68 degrees right here, okay? And I always say in all of my problems, go for what you know. You know that you've got 35 there, and you know that you've got 16 degrees there. So I'm going to start with this, and I'm going to do the math on this. Let me change the color of the pens. What do I know right now about this angle? That I've got 90 degrees here, and I have a total of 68 from here to here, but that's not my size from this point to this point, is it? No, that size from that point to that point is going to be 68 minus 16, right? And that's going to be 52 degrees. So that's what you have there. So if that's 52 degrees here, I'll put 52 in here so we kind of keep that, or keep track of that. And if that's 52, then what's this over here? $38. Okay, mark those in. The next one that I'm going to go for, again, I'm going to start from a point that I know. I know that I have a point from here. Oh, darn. Make this a straight line, not one that's all raggedy. So from here to this center point, right? Is the distance from this point out to here, this radius, to this center line, the same as from this radius here to this center line? Yes, it is, because that's a radius, right? And what does it do? It shares the same plane. So if it shares the same plane, that means that that's a congruent or equal angle. So that means if I can solve for this inside here, I know what this is here and here, because it has to be the same angle here as it is here, because it has the two same sides and it shares the same plane. So in that case, what I'm going to do is I'm going to take 90 degrees, Wow, that's a bad 9. Sorry about that. 90, let me try to fix that a little bit. Plus 35. Wow, that's a horrible 0 too. Looks more like a square. Plus 35, but you get the idea, right? Okay, so what's that going to be? 125 degrees, right? So that is what this is from this point around to here. Let me make that just a little thicker. So when you do the math on that, you know that you've got 180 degrees because all angles are 180 degrees. So I'm going to take 180 degrees and I'm going to subtract 125 degrees from it, okay? Because we know that we had 125 degrees here. That's going to give us 55 degrees. Divided by 2 because they have to be equal, because if this side is the same length as this side and it shares the same plane, they are congruent, they have to be equal. So you're going to come up with 27.5 degrees from here to here, and 27.5 degrees from here to here. Okay. So on this next one, what I've done is I've taken this red line, moved it up here, and I've taken this black line and I put it right here. Okay. So I know that this straight line plane here is 180 degrees. I know that I have 35 degrees here because it says so. That's what this is here. And I know that I have 16 degrees here because it says so. That's what it says here. So I'm looking at this whole thing like this, and I know that that's a straight plane. So if I took 180 degrees, minus 35 degrees, that's that one, minus 16 degrees, that's that one, that gives me 129 degrees. That's what this is here. So this is 129 right here. And that's what that angle is inside here, right here. Okay, there's 129 degrees. So if that's 129, this angle here and this angle here have to be exactly the same, don't they? Because we're looking at this plane being the same as this plane, and it shares the same surface. The distance from this center point to here and the distance from this center point to here is the exact same size because it's the center point to the outside of the radius, and it shows that plane. So let's draw that one in. Therefore, what we're looking at is 180 degrees, which is the full triangle, minus the 129 that we got right here. This is 129 here. Gives us 51. So it's 51 degrees total divided by 2. So this is going to be 25 and a half. And this angle is going to be 25 and a half. Okay? So now we're getting a whole bunch of stuff going on here, right? We've got a whole bunch of things going on here. Not sure what else we're going to find, but at least we've got some things going on. So then to solve for this one, this angle right here, I'm going to take 360 because it goes all the way around. Remember, a circle is 360 degrees. So I'm going to take 360 minus the 68 from here to here, minus the 129 from here to here, minus the 125 from here to here, and that's going to tell me what's left over, which is the 38 degrees. Okay. Now, do I need that or not? I don't know, but I'm going to put it in there just in case I do. Okay, so we've got another angle that we can come up with here. We've got this one right here, like this. What color I'm going to use? Let's see. So it's getting pretty messy. I've got this color in here though. And I know that I've got 68 here. From here to here, all the way over, from this magenta line. I've got it blended with this blue one, so it's the start, the center point from here to the outside, center point from here to the outside. I have this magenta color line blended with this blue one. So 68 plus 38 equals 106 degrees, right? 180 is all triangles, so 180 minus 106 gives you 74 that's left over for the total of this and this. So if you take 74 and divide it by 2, that gives you 37. So you have 37 here and you have 37 here. Now you can come up with F. F will equal 37 plus 25 and a half, right? 37 plus 25 and a half. So the 37 plus 25 and a half equals 62 and a half. So I put that down right there. Okay? You have that? Hope that's good for you. Now, can you solve for this one inside here? This E? Most likely you can. Why? Because you've got this distance here now, which is 37, and you have this distance over here, which is 27 and a half. So I'm going to just stay in the same color that I have here. So I'm going to just take the 37 plus the 27 and a half. Okay, write that in. Okay, so again, how did we get that? We know that it's 37 degrees here. It's 37 degrees here. We know that we've got this distance right here of 27 and a half, and this one's 27 and a half. So 37 plus 27 and a half equals 64 and a half degrees. All right? Now all that's left is D, this total distance here. So how are you going to get that? Well, let's take a look at something. Okay, so now what we have to do is just one more triangle. And I'm going to make it a little bit larger, or quite a bit larger. And we know that we've got to come up with this right here, right? We've got to come up with this, come down to here, coming over here to this down here, to come up with what this angle is here. So we're really looking for this inside here. So how are we going to get that? Well, the way I would do it is I would shorten this triangle just for a moment right here like this, okay? Now, remember that all triangles have to equal 180 degrees, right? So what if we just took this and we just extended this out just a little bit further? And we extended this out so that it just comes like this, all right? My numbers don't really, and the angle doesn't really fit real good, but you're getting the idea here. So what I want to do is make it from this point all the way up to here, down, and then back across like that, okay? So kind of forget about this thing inside here. Now, what do we know about this? Well, here's what we're looking at. Here's what we're looking at. So let me grab a different color. We know what this is here, right? This is 25 and a half degrees from here to here. Do you know what this is here? All the way around? Well, sure you do. You know that you've got 129 inside here from here to here. Let me make this a little bigger and darker. Okay, so you know you've got 129 from here to here because that's what it was off of here. So we've taken this 129, this piece right here. And I'm going to add 16 more degrees to it. That's going to be this thing here. So 129 and 16. So add those together, 129 and 16, you're going to come up with a number of about 145. Right? That's going to be 145 from here to here. And if that's 145 and that's the 25 and a half, let's put the 25 and a half in here. Let's add those two up. And you get 170.5, right? That's what that is here. So if you take 140, or you take this 145 here, and the 25, that gives you 170.5. So how much is left here then, coming off of a 180? You're going to have inside here 9.5 or 9.5 degrees, right? All right, so if that's 9.5 degrees here, because we're going off of this, you can now add this whole thing together. Why? What are you going to come up with? D? D is this distance from here to here, which we came up with as 9.5, right? It's 9.5 this whole way. It's 9 degrees, 30 minutes. Okay, this whole thing here is 9 degrees, 30 minutes. And this is 38. So take 9.5. I'm making a big mess here, but I'll bring this down here like this. 9.5 plus, what'd you get for this angle over here? 38, right? From this edge to this. You figured that out before. That's why I've got this mess on here. Yeah, it's all over the place, but the bottom line is you have to have that stuff on there. If you don't have numbers down, you're kind of stuck. So your answer for D is going to be 47.5 degrees, 47.5. Remember, this is degrees, decimal degrees, and you're going to have to convert these to degrees in minutes, which means that's going to be 47 degrees, 30 minutes. So this answer here is going to be 47.5 or 47 degrees, 30 minutes, 62 degrees, 30 minutes, 64 degrees, 30 minutes, and there you have it. What you thought might have been a really difficult problem has a lot to go in there. I mean, there's a lot of different angles going in there. You look at it, it's a whole big mess. If I had a bigger screen, we could have mixed these numbers up, put the numbers around different places. If I could have erased things and put slides over and everything else, I mean, that would have been slick too. But the bottom line is I've taken you step by step, and now you should pretty much understand. Thanks, and I hope you had a great day. Hope you had a good time with this, and we'll see you on the next one. Take care.